It's almost midnight here when I'm filming this video, so it's quite late, but good evening, I suppose. I hope you're all doing well or watching to my 30 subscribers, each and every one of you, and minus five because I think five of them are myself. But today we're going to be doing I'm going to be making a video, a user requested video. So this is to answer the comment from learner 7040. I was meant to do this 5 days ago, at least. So the comment was left 8 days ago. I said I'd do it within 3 days, and I haven't. It's been 8 days, so we're doing it now. I do apologize if it's a little bit more rushed. It's not as well thought out. I do have a basic plan, but this is for you, learner 070. It's late, I'm sorry. This is for learner 7040. And if this video, if you don't find it as helpful as it could be, if you still have some questions, feel free to just flick me an email, um, and we can just arrange a time to hop on a video call or an audio call or whatever. Um, wouldn't cost anything. We can just go. If you have any questions, I'd be happy to answer them. Um, just related to electronics and sort of PCB design. But in this video, we're not going to actually focus on Altium Designer. I have a video on importing components in Altium Designer, and there's tons of great resources online as well, better than what I can explain because um, I haven't been doing this all that long, so I'm still learning myself. Uh, I I initially intended to actually have a part on Altium Designer in this video, but I don't think we're going to do that. I think what we're going to focus more on is the part searching using Octopart, and then what do you do? How do you do the importing process with a different online library of components when you're downloading from a different online library of components, such as SnapEDA. Um, we're going to import them into KiCad, and um, and that should hopefully answer most of your question, I hope. So, importing components from other sites, DigiKey, SnapEDA, component search engines. Also compare importing parts in KiCad versus Altium. So, just refer please to this video for importing components into Altium Designer. If there are any more questions you have about it, please do ask as well, and I'll do my best to answer them. If I say 3 days, it's going to be 8 days. That's um, at least until mid-September when I sort of have a bit more free time. But I do encourage questions up. I do encourage a lot of questions. I think it's a really great way of learning and challenging what you think about or how you understand an idea or a concept. So we're going to do two examples in KiCad. The first is with this component here, the CC1101. So I just went to Octopart, CC1101, type in the component. It's a sub 1 gigahertz wireless transceiver, I think. I was looking at it today, but I don't quite think it's going to be useful for my application. And Octopart is going to return 125 results. We want to scroll down until we find what we need. We have this part here, the CC1101 RGPR from Texas Instruments. We have different distributors or suppliers that we can purchase these from. So DigiKey, Mouser, the two that I've used DigiKey before. I've not bought anything from Mouser before, but I've used their what do you call it? Their websites, filtering and search tools to find parts. So I think that I would purchase from Mouser as well. I've not had a look at any of these other ones before. They also have a significantly less amount of stock as well. So once you're here, what you may want to do is you want to maybe add this to your bill of materials. Octopart have a BOM tool, which we're not going to discuss in this video. I intended this video to be really quick as well, in all fairness, but we're not at the moment. So this is the CC1101. Some manufacturers, like Texas Instruments, will actually link uh, your ECAD and your regular CAD files for their products on their website. And Texas Instruments are really great for doing this. I don't know if they do it for all products, but all the products I've seen, they do. So we can go to design and development. We have all hardware development. They have these evaluation boards you can buy. Software. I've never used any of the Texas Instruments software before, uh, so I'm not entirely sure what Smart RF Packet Sniffer is used for. It does say it's a PCS software application that can display and store radio packets captured by a listening RF device. Captured device is connected to a PC via USB. Various RF protocols are supported. The sniffer filters and decodes packets and displays them in a convenient ... I do have a really fun upcoming project that maybe that'll be useful for. Given that I use one of Texas Instruments, uh, some of their hardware for it, which I'm not entirely convinced I will. I don't think I'll use the CC1101, but I'm digressing. We can come to the CAD symbols, footprints, and 3D models, and they have they use Ultra Librarian to distribute these models, so we can download them. So we can click on this link, and we get brought to this page. I'm just going to copy this link into Firefox because I was having some difficulty beforehand. Downloading these files, and I'm not sure why. But you can select different views. We're just going for the basic view. We want to select a step file for our 3D model, and I'm using KiCad version 6 Plus. I'm not a robot, which is pretty cool. We want to select, I prefer the millimeters instead of mils. I also will say mils to talk about millimeters. If I say 10 mils, 150 mils, it's not English mils, it's millimeters. That's just how I've sort of grown up speaking that, abbreviating that unit. So it is a bit confusing when it comes to PCB design. So I will try and say millimeters, but I prefer to use millimeters over mils. I think mils are some sort of amount off an inch. So from Ultra Librarian, we've had this component's been downloaded, which is really nice. I'm just going to close out of some of this stuff here. So the next thing before we start importing these components is I've looked up this part here, the MC3416. It's a 3-axis accelerometer. I've never used it before. Accelerometer XYZ. 3-axis accelerometer it is. It's just one I found on DigiKey while I was sort of very loosely preparing for this video. So same thing applies. We can use Octopart as our component search engine. We can look for the part that we want. Let's have a look at this one here. You can see who it's manufactured by. This one was on Semi, but this says MEM6, so they might be different manufacturers for the same chip design. I'm not entirely sure. Or I've entered the wrong thing in MC3416. MC3416. See if we can find the right one. Because all I have done is just copy this manufacturer's part number. Maybe we can copy the DigiKey part number into... I know this is sort of working backwards at the moment, but I'm not going to worry about that too much. You can still use Octopart to find different parts. So one of the, if I can find where it is, which I can't. Um, well, once we search up this component, we have our different suppliers or distributors. DigiKey and Mouse are two notable ones that I would use. Um, DigiKey is really good, and they ship really fast. I'm not based in the US. I think they ship out of the US, but the stuff arrives within a week. Really, it's pretty quick. Um, so we can select this link, and I think this is going to take us to DigiKey. It will, and it's taken us to the same page as what we expect. We entered in the DigiKey part number. Before we finish up with Octopart as well, they do have this parts by category. If you have got any other sort of, maybe you're looking for a particular resistance that can, or sorry, a particular resistor that can work with a certain amount of power. You want to be able to pass a certain amount of power. So maybe it's a high power application you're designing for. Um, and that, if that's the case, you can probably come into passive components here. You've got resistors, capacitors, crystals and oscillators, inductors, and so you can sort of try and navigate around this website. Once you select the product that you want, we want resistors is the passive component. You've got SMD surface mount resistors through hole, ones I've never even heard of before. You've got um, wire 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 wound resistors. I think those ones look like they might be pretty good for high power applications. They look like quite big resistors, which makes me think they'll be able to withstand a high amount of current um, flowing through those resistors. But maybe you're looking for thermistors, for example, resistors that will change based on the temperature of the environment. And I actually do have a video, a good video, a better video than this planned for talking about thermistors, trying to make them a bit more easy to understand. Some of the maths and the coefficients can be a bit sort of scary maybe for someone wanting to use one for their application, but it's really not. They're really friendly components. So I do encourage you, whoever's viewing this, in particular, learner 7040, yeah, have a play around with Octopart, see if you can figure out some tools, what some tools are that I haven't really talked about here. They've got parts by distributors, by manufacturers. You'll probably find manufacturers you've never even heard of before. I can already 5 or 6 of these I've not heard of. One, two, three, four, maybe four. They've got some popular parts, and this looks like some sort of newsletter that they publish as well. So I encourage you to have a look around. We come to DigiKey with our 3-axis accelerometer. We haven't even got into importing components yet. Oh my goodness. We'll get there. It's late, so I do really apologize. And DigiKey here, they allow you to download a datasheet, which we can view the datasheet, but we can view the datasheet for the product. It's a small form integrated digital output 3-axis accelerometer with a feature set optimized for cell phones and consumer products and consumer product motion sensing. Applications include user interface control, gaming motion input, a mouse possibly, some sort of joystick or a controller, electronic compass tilt compensation for cell phone game controllers, remote controllers, and portable media products. So quite nice that we get some packaging in the data sheet. Some pinout. This might be useful as well for verifying. If we come to now, sorry, we're jumping around a bit, but if we come to SnapEDA, sorry, SnapMagic, SnapEDA, for downloading this component, I'm just going to copy this part number. This is just another online database similar to Ultra Librarian, I think. Maybe how they build their components are a little bit different, I'm not sure. And I've just typed in that part number there. And we want the one from this company here. I'll just type it in memsic. We'll see if that returns any better results for us. It should do, because I looked up this part beforehand and it looked like it was available on SnapMagic, SnapEDA. But now it's disappeared. Let's try this one here. I think it's the same, but it's with a tape reel on the end. So it's late. I'm not going to worry about it. This is probably a very similar product. You can see here that the datasheet's available, the symbol's available, the footprint's available, and we have a 3D model available. So that's very nice. There's no, I think the last one was simulations. If you want to perform spice simulations, which I've just done only a very, very small handful of times. So I'm I don't really understand it as well. Just while talking about that, we've already downloaded something. We wanted the symbol and the footprint and the 3D model. How do we download the 3D model? We may already have downloaded the 3D model. We'll have a look. We have a step file here, which is the 3D model. We have our KiCad symbol and KiCad _mod. I'm not sure. We'll figure it out. It's possible we just didn't download the footprint, so we'll do that as well. I do allow downloads from this site, which is alright. Yeah, so it looks like we have downloaded it twice. Not too worried about that. And we've also got this file here, so we've got everything downloaded we need. I've talked for a lot, sort of gone on and on for a bit. One thing worth mentioning, I think, and it's jumping around a little bit more, but and actually, or two things maybe. This component actually does look different to the one that we found on SnapEDA. That is a problem. I'm not going to address it tonight. I'm too tired. Let's just assume we were wanting the one that we found on SnapEDA, just to keep the video going. Depending on how you manufacture your PCBs, you might want to check whether or not the manufacturer has the part in stock. I like to use JLC PCB. I've ordered PCBs from them before, and the quality is good enough. It's very good. I have limited experience with. I'm sure you can get better quality boards designed and developed, but the boards that I've had made from them have worked really well. I would recommend them. And so one thing you might want to do is you might want to look up this part, the MC3416 here. You've got two different parts, but specifically looking at how much stock here that the JLC PCB have. They have 30 in stock. You only have to order one of them. They have a minimum order of one here, and they cost $1, probably $1.06 US dollars. So like $1.70 where I am. And that's important when you're designing, because if it's a very difficult component to source, or you have to order in and and there's a minimum order quantity, then that might be just a surprise cost or time delay to your development process. So just making sure that the components available where you're getting them manufactured, if you're getting them assembled, your boards assembled as well, isn't a bad idea at all. So let's move on to importing these components. Let's open up KiCad. Let's not check for updates. I've just installed KiCad, to be really honest, so it's been a long time, but we'll get there. We'll go to the downloads and we'll open up our first one. We'll do our Ultra Librarian. First of all of these all of these components from SnapEDA, Ultra Librarian, these two suppliers of files, they come with installation instructions as well, and they're very useful. So I think I'm going to put more emphasis on how I sort of utilize these instructions and what do I do when the instructions aren't quite right or I don't quite understand something, rather than this is how I do it really quickly because I've done it 100 times, because I haven't done it 100 times. So we're going to just come and click KiCad v6 plus because we're using version 6 plus. And this is going to, if we click KiCad version 6 plus, this is going to walk us through what does it say here, and the instructions that follow explain how to import files you download into KiCad. So I think this will do it in two parts. You'll do your schematic, you'll do your footprint, and you will do your CAD model, which we want to do as well. Quite the process, really. Okay, so first of all, we want to create a new project, which we should do. We're just going to, file, new project, untitled project is fine. For a demonstration, it's okay. I don't recommend not titling your projects. We're gonna copy the. I don't think I read that properly. It's so late. I read it and I didn't process it. If we come back to this website, we want to go to Preferences, Manage Symbol, Libraries. If importing a project-specific part, select the Project-Specific Libraries tab. But there's global libraries which will be available for all of your projects and project-specific libraries. We'll do project-specific libraries. Add a part, select the folder, and select this library folder. Well, I don't know what Firefox is up to. Let's not worry about it. So we'll come to where was it? Preferences, Manage Symbol Libraries. Let's add a project-specific one. I don't remember if I said I was going to do global or project-specific. We want to specify a path here. So for me, it's my downloads. We want to come to our CC1101 is what we downloaded. Come to our KiCad folder, and we have a footprint. We have this file here. I don't know if it says it's a symbol library folder, so that's perfect. Go ahead and click not okay. It's not very happy. We'll call it CC1101. I think that's what it wants there. We'll go ahead and click OK. And we'll keep following through our work. Our installation guide. Select the folder icon under library path to open the file browser. Yep, we did that. Browse to select the date.lib from your Ultra Librarian download. Click OK. You now have added the library. You can place it into your component schematic. Cool. So let's just verify that. If we're placing a component in Altium, I think it's press A to open the symbol libraries, configure global libraries. We'll just hit OK. And if we type in CC1101, this here is the component we just downloaded, RGP it is. So we can go ahead and place the component. What do we do next? Select preferences, manage footprint libraries from the menu. But we have to have a PCB file, so we'll go and create a PCB file, switch to a PCB file, which will create us a PCB file. Go manage footprint libraries. A similar process, I think. Go back to the project specific tabs, click on the add button, select the folder under the icon and click OK. And then place add footprint. What's next? Select the desired footprint from the list, click place the footprint on the PCB canvas, select the footprint, right click and select open a footprint editor. Alright, I think we can do that. That's not too much stuff. We'll call it the same thing, the same footprint name. Go back to downloads. Come into our footprints. What does that say? Footprint's not pretty. I think that's what it said. Hit OK. We want to place that footprint. That folder contained 3 different footprints, so we've got any of these we can select. So we'll just select this top one, place it, and zoom in. It's very small. We'll select it, right click it, and select it, right click, open in footprint editor. Now this is where we can add in our go file, footprint properties, file, footprint properties, 3D models. We want to browse for, we want to browse like this, taking us back to KiCad, downloads, KiCad. Did we not get a, no we did, we got this STP, the step file here, and you can see that's put that model correctly on our footprint, so we can click OK, save that and close out of that. If we wanted to save this, save this we can. We press 3, is it? Or is that LTM? Option 3 in KiCad on Mac to open it up. And that looks really nice. So the only other thing I can think of is I seem to remember there is a button up here. If we select footprint editor, no. Might be this here. No, is that the same thing? It might be. Annotate schematic. We don't want to do that just yet. Electrical rules checker. Assign footprints, I think it is. Some of the assigned footprints are legacy entries with no library names. Would you like KiCad to attempt to convert them? Alright, that's whatever. Cool, so if we click on this symbol U1, which is our designator for the component, that has, I think, to do with how we imported the component. It's already selected the right footprint. So we have this default one. We have the L in there. The M, I think that says. So we can just hit OK. Knowing that these two footprints are related. So that's the first one in KiCad. We're just going to put this out of the way. And we're going to repeat the same process as quick as I can because I'm really tired. I want to go to bed. This video's already been going on. It must be almost half an hour now at this point. It's too long. So we'll come here. We've got another how to import, so we're going to go to Safari. It'll be a very, very similar process. In fact, let's just try the same process and see how that goes. So we've downloaded the SnapEDA components. Whoops. We're going to go to Preferences, Manage Symbol Libraries. We want to add in another project-specific library. And we're going to select this time our symbol here. And I can't copy that name. It's the MC3416. MC3416. Select OK. Press A to open up your where you can choose your symbols. And we have this component here, the MC3416, that we downloaded from SnapEDA instead of Ultra Librarian. You can see the footprint even looks a bit different as well. You can edit these schematics, and there's plenty of good tutorials online that I recommend following through for doing that, for understanding how to do that. I'm not going to do that in this video though. The next thing we probably want to do is switch back to our PCB. Let's do the same thing here. Let's press A to open up our footprint chooser. I don't remember what we called the component, the MC switch back. MC3416. Let's see if we can find that. We won't find it actually because we haven't added it in yet. So if we go MC3416, we have a symbol that we added in our schematic editor, but we need to add in another component here, MC3416. MC3416. This time come to this folder, and we're just going to open this folder directly. If we search up MC3416, this is our footprint that we downloaded, and we can actually, if we come back to SnapEDA, we can verify that this is the same part that we downloaded. Not that you'd probably need to, but it's late and now I'm sort of second-guessing myself a little bit. If we click on this one here, we can see our symbols matches and our footprint looks very, very similar. So we'll go ahead and select it. Select our whole footprint, right click, open in footprint editor. This is to add in the the 3D model. Go footprint properties, 3D models, add it in, select the folder. In our downloads, we have the step file here. And this is a really good example of when it doesn't import correctly. We want to rotate this, so we can use, oh, sorry, I don't know what I'm up to at the moment. Go back to footprint properties, 3D models. That's the scale. That's why nothing's happening. We want to rotate this. I'm pressing enter and it's not doing too well doing that. So we just need to rotate this 0 degrees. We just needed a 90-degree rotation on the x-axis, and now you can see that's aligned properly. You've got this white marker here indicating the top leftmost pin, and then the pin order will be 1, 2, 3, 4, 5, 6, 7, 8. Which 1, 2, 3, 4, I think that's what it said in there. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Either way, that's how you can add in the footprint. We'll just save that. And if we come back to our schematic, and we come back to, just Is there a selection tool? Here we go. Our assign components, assign footprints, sorry. This one here, we want to search for the MC3416, and that is that's our footprint that we assign. Assign footprints. Apply, save schematic, and continue. I'm just wondering why this one's yellow and this one's not. If you know, please let me know. I might look it up after this video, but we're not going to do it now. Either way, this is how you can. This video has been a very long and probably too long video. I probably could have condensed this down by at least half, but how you can import components from other sites, DigiKey, SnapPDA, or if you've got a part that you found on DigiKey, maybe you can then look it up on SnapPDA. Maybe it's got a data sheet or a link to a supplier like Texas Instruments directly, where you can, where they suggest a resource for downloading your KiCad models, and using Octopart as well. And then not directly comparing it, because we didn't actually do any LTM work today, but how to import components in KiCad. And again, before I go, if this is just, actually I suppose it applies for anyone. If you've got any questions, just feel free to leave them in the comments, or alternatively, just flick me an email, and that works just as well. In the next video, I've already planned it out. We're gonna be doing either the thermistors that I was talking about, a video on thermistors, and I'm not gonna film it at 12:30 in the morning, so it'll be a lot more put together, and there'll be a bit more effort in it. But I just wanted to get this done for the fact that it was 5 days over. So that, or a video on, what was it? Live expressions in the STM32 IDE, and just using them as a more powerful debugging tool, because the debugger is really good if you've got one of the Nucleo boards. If you're using an ST-Link for debugging, there's some incredibly powerful tools, and I want to talk through some that I use. And other than that, like and subscribe. Feels a bit weird saying that. Or don't like and subscribe. In fact, unsubscribe, so I don't have to make these videos as often. But I'm going to keep making them slowly, inconsistently, but we'll get there. After September, I'll hopefully I've got something really exciting coming up. I think it's exciting. We'll see. It's not a tutorial. It's a bit more of it's an educational video. But it's a lot more. Let me watch it with a cup of tea kind of thing, rather than let me watch it with a headache, which I feel like comes when you're doing research and having to look through 30-minute long tutorials on trying to figure something out. And yeah, I'm not helping by making this video so long. Before I go, my advice for the day: brush your hair, floss your teeth. Yeah, keep clean, be kind, and there's no reason, this is a very important one, no reason that you shouldn't be, oh man, what are the words? How do you say it? Just keep a high standard. If there's a problem, fix it. If you see something that's not quite right, fix it. If you're, I don't know, if you're in your room and there's a dirty dish on the floor, fix it. If you're on the street and you see some rubbish, pick it up, put it in a bin. It's not hard. It takes 2 seconds. Yeah. Just keep good high standards. Something I'm working on. It's something that with some training that I'm doing at the moment, each week. It's like that's you know a pretty applicable lesson. It's late. I'm gonna finish the video. Hopefully it was somewhat valuable despite being how long it is, and we'll see you in the next one. A much shorter next one. A much shorter next video.